Hello. So last lesson we looked at how logarithms are just another way of writing exponentials. So we looked at an example of 10 squared is equal to 100, and we could rewrite that as log to the base of 10 of 100 is equal to 2. And we had a general form which we looked at where we said that a log to the base a of n is equal to x, and that's equivalent to writing then as an exponential a to the power of x is equal to n. So today we're going to look at the laws of logarithms, 3 laws of logarithms, and before we do that, first thing is we're going to look at a property of logarithms which we looked at last lesson. So what we looked at a question which said log to the base a of a to the power of 5, and we found our solution was 5. So if you have a base and a number raised to a power, then whether the number raised to a power and the base are the same, our solution is always going to be the power. So if say if we had log to the base 10 of 100, our solution is going to be 2. Log to the base 10 of 1000, and our solution is going to be 3. And if we look at log to the base 2 of 8, our solution is going to be 3, because of 8 is the same as 2 to the power of 3. Log to the base 2 of 2 to the power of 3 is equal to 3. So these are the 3 laws of logarithms. Log to the base a of x times y is equal to log to the base a of x plus log to the base a of y. It's the multiplication law. Log to the base a of x divided by y is equal to log to the base a of x minus log to the base of a of y, division law. And log to the base a of x to the power of k is equal to k log to the base a of x. That's the power law. These are 3 laws of logarithms you need to know, and you need to know how to prove them, which is what we're going to do next. You want to pause it, make your notes, and then we're going to move on to the proof next. So with logarithms, we have to get used to the idea that they're basically another way of writing exponentials, writing indices. So we have to get used to that idea, and that helps us with proofs. So we've got a multiplication law first. Log of base a of x times y is equal to log to the base a of x plus log to the base a of y. So I'm going to take log to the base a of x, and I'm going to rewrite it. Then I'm going to say that's equal to m. I'm going to rewrite it as an exponential. That's going to be a to the power of m equals x. And I'm going to take log to the base a of y. I'm going to say that equals n, which is equivalent to a to the power of n, which is equal to y. So if I multiply x times y, that means that x, y is going to be equal to a to the power of m times a to the power of n. Now I know from my law of indices, xy is going to be equal to a to the power of m add n. Okay, so I'm going to take logs on both sides of the base a. Log to the base a of xy is equal to log to the base a of a to the power of m add n. Now earlier we looked at a property where we said if we have a base and a number raised to a power, then the solution for that is going to be the power. So that means that log to the base a of x times y is equal to m add n. So I can rewrite that. I can say log to the base a of xy is equal to m is up here, and I said that m is equal to log to the base, there it is, log to the base a of x equals m. So m is equal to log to the base a of x, and n is given by log to the base a of y. So that's plus, which is what I set out to prove. So that's job done on the first one.